In this question, we're going to consider the following scenario. Jason has $7,500 that he'd like to invest for 6 months. However, there are two different rates offered. We could deposit our money for a 3-month term and obtain 5.25% simple interest, or we could deposit our money for a 6-month term and earn 5.4% in simple interest. And he's trying to determine which one is the better deal. Should we put our money in for 6 months at 5.4%, or should we do 2 3-month terms at 5.25%? Well, let's do a couple quick calculations to figure that out. If we want to do a single 6-month term, we could take our $7,500, multiply by our simple interest rate of 5.4%, and then multiply by 6/12 to represent our 6 months. And simplifying this expression, we get that we would earn $202.50 in simple interest. If we go the 3-month term route, we're going to take our $7,500, multiply by the 3-month percentage, which is 5.25%, and then multiply by 3/12. In our first 3-month term, we're going to get $98.44 in simple interest. And then what we do is we turn around and we reinvest our initial principal amount of $7,500 plus that simple interest of $98.44 that we obtained during the first 3-month investment. Altogether, this is $7,598.44. We're going to multiply that by our simple interest rate of 5.25%, and then again multiply by 3/12, or our time variable. And here we get interest of $99.73. And if we were to add up our interest of $98.44 and $99.73, we get a final total of $198.17. It's a little bit less than what we would make in the 6-month term. So we can see with a couple simple calculations, the 6-month term is the way to go. And so the question we want to pose is, what percentage could the bank offer so that one 6-month term has the same amount of final interest as 2 3-month terms back to back? And in order to determine the interest rate we're looking for, we're going to update our 2 times 3-month column a little bit. So let's calculate how much interest, let's call it interest 1, we're going to earn during that first 3-month period. We can use our I equals PRT formula. We're going to deposit $7,500. We don't know the rate we're looking for, but we do know it's a 3-month term, so we can multiply by 3/12. If we take $7,500 and multiply by 3, then divide by 12, we end up with $1,875. We're going to multiply this by R. So this is an expression for the amount of interest we're going to earn during that first 3-month time step. In our second 3-month period, we're going to take that interest that we earned and we're going to reinvest it. So we're going to take our initial principal amount of $7,500, add to it interest 1, multiply by our simple interest rate, and then multiply by our time variable of 3/12. If we distribute through the brackets, we get the following. We already know that 7,500 times 3/12 is equal to 1,875. Next, let's make a substitution. We know what I1 looks like. It's 1,875 times our rate R. And if we multiply 1,875 times 3/12, we should get 468.75. And then we need to multiply our 2 r's together. We're going to end up with r squared. So this value is I2. This is the amount of interest I expect to earn after the second 3-month time step. Now, in order to finish off our question, we're going to try to solve for r. And what we want to do is we want to compare the 6-month interest of $202.50, and we want to add up the two interests that we got during our 3-month periods. Our I1 was 1,875 times R, and then our second interest that we received was 1,875 R plus 468.75 R squared. So we want these interests to add up and be equal to each other. Let's go ahead and collect like terms on the right-hand side. 1,875 plus 1,875 is 3,750. Now I notice that this is a quadratic equation because we have a power of r squared. So I'm going to subtract 200 and 250 from both sides and reorganize the terms inside of this equation to make it easier to use the quadratic formula. So let's go ahead and label our coefficients as a, b, and c. And in order to solve for r here, we're going to apply the quadratic formula, which is negative b plus or minus b squared minus 4ac under the square root, all divided by 2 times a. And making our substitutions in for a, b, and c, we get the following. Now it looks a little bit complicated, but we can use our calculator to go ahead and help us simplify this square root. So let's start with 3,750. We're going to square that. Then we're going to subtract 4 times our 468.75. And then multiply by 202.50. And make sure that we use the plus minus button here. We're going to make that a negative 202.50. And then let's hit equals. So this is the number that's underneath our square root. If you want to find the square root of this number, we can use the square root button. So let's copy down this number that is around 3,800 into our numerator in place of that square root. Next, let's multiply the two numbers inside of our denominator. So 2 times 468.75. And that gives us 937.5. Now the quadratic formula does give us two possible final answers. It gives us negative 3,750 plus the 3,800, or it gives us negative 3,750 minus our 3,800. Now the rate that we're looking for is going to be a positive rate, so we can probably ignore the negative 3,750 minus 3,800 answer in favor of just taking the one single answer where we add our two numbers up in the numerator. Adding up the two numbers in the numerator, we get about 50, and we're going to divide that number by 937.5. And so we get a final value for r that is about 0.05364. And what does this mean? This means that we would be looking for a rate of about 5.36% simple interest on our 3-month term investments in order for the interest to be equal to our investment that goes through the single 6-month term.